Find the perfect factor. 27. The two terms that can go into 27 are 9 times 3, because 9 is the largest perfect square that can go into 27. And the square root of 9 is 3, so this becomes 3 square root 3. There is always a positive and a negative answer, but I'm not worried about that right now. So when we get to the back, that's when we're going to be make sure that we have a positive and a negative answer. Whenever we're doing a square root, there's always one of these. Think about when we were solving quadratics, how we always had two answers. Sometimes we had one, those occasionally, and then or no answer, no solution. Okay, so those are still going to be our options here. Okay, 80. We can break apart 80. So what I like to do is I start off, okay, so 64 is the smallest perfect square that's below 80. Can 64 go into 80? No. Then I try 49. Can 49? No. Can 36? No. Can 25? No. Can 16? Yes. 16 times 3, or 5, sorry, 5. And the square root of 16 is 4. And then we have the 5 on the inside. Okay. Yeah. Unless we're dealing with when we're solving later, we're dealing with a real world situation, we'll find the approximate answer. That will be like if shooting a basketball that creates a parabola. Okay, when it says that it's 4 and 5 square roots to the second, okay, 4 point whatever. You'll see. All right, so we're going to break apart 96. So we're going to do the square root of 16 times 6. 16 is the smallest square root that goes into 96. And the square root of 16 is 4. And then the 6 is remaining on the inside. If I chose a number that wasn't 16, let's say I chose 4. Okay, so 4 is the perfect square, and it does go into 96. But it's going to leave me with a number on the inside that can also be broken apart. Okay, so that's why we have to choose the largest number that can go into 96 as a perfect square. So I have a list of perfect squares there. You're going to try them, or you can work backwards. I could have divided by 1, or 2, 3, 4, 5, and then I get to 6. And it means that 6 is the first one that gives me a perfect square. Okay. So I'd like for you guys to try number 4 on your own. Oh, it's this. So how did I get that? Or blah, blah, blah. I didn't understand that. So what did you get? Anna, what did you get?
I got 100 times.
That is what I got as well. So, what we can do, two ways of doing this. Okay, you can start off by taking 200 and dividing it by all of the perfect squares that are listed above. Okay, that starting with the ones that are smaller than it that are large. Okay, so like starting with dividing by 196, that doesn't work. 169, that doesn't work. Dividing by 144, that doesn't work. Or you can go the other way around. You can divide by smaller numbers like 2. I would divide by 2 and I would get 100. I would see if 100 was on that list. If 100 is on that list, then my two numbers are 100 and 2. If 100 wasn't on that list, or if I didn't get a number that was on that list, I would try the next number, 3. See if that number gives me a number that's on that list. Yes, Kara?
How would you say
10 square root 2. Okay, so number 5 here. We're breaking apart 32. What perfect square goes into 32 evenly? Cody? 8 is not a perfect square. Kara? 16. 16 times 2 is 36. And the square root of 16 is 4. And then the 2 will be inside of my radical. So this would be 4 square root 2. Okay, so this next one is a little bit different. So with number 6, we have a number on the outside of my radical. Whenever we have a number on the outside of a grouping symbol, a radical is a grouping symbol, what operation is being done? What if I had a 3 on the outside of parentheses? We'd be multiplying, right? Okay, technically. So this is technically a multiplication problem. That's going to come into play after we break this apart. So I'm going to break apart 75 first. What can I break 75 apart into? What perfect square goes into 75? 25, and it would be 25 times 3. And the square root of 25 is 5. So I'm going to have 3 times 5 with the square root of 3 on the inside. So I'm going to have 15 square root 3. Okay? Because I'm multiplying. You're going to multiply at the end. Because this radical symbol, we do our grouping symbols first. Okay? In order of operation. And our grouping symbols first. Okay, radicals and exponents are on the same level. Okay, so for this next one, I'm going to have a negative 2 on the outside. Okay, I'm going to break apart 54. What can 54 be broken apart into?
9?
9 times 6. And the square root of 9 is 3. And negative 2 times 3 would be negative 6 square root 6. Yes, sir. What do you mean? We won't have a decimal on the inside. Okay, you're going to have they're going to be whole numbers, and you need to break them apart into whole numbers. We're not breaking apart into decimals. That's why we're using perfect squares. Okay? All right, so there's 2 ways that we can solve this next one. We can multiply the 8 and the 12 and get the square root of 96, and then break apart 96 into 16 times 6. And then the square root of 16 is 4 square root 6. Okay, so that's one way of doing this. Or we can break apart the 2 factors beforehand. So I can break apart 8 into 2 times 4 and 12 into 4 times 3 and get 2 square root 2 times 2 square root 3, then multiply the numbers out front and get 4, and multiply the numbers on the inside and get 6. Okay, the bottom way takes more time, I guess, more writing. However, you're working with smaller numbers, so it's a little bit easier. Yes. Okie dokie. So now we're going to take this one step further. Okay, we're going to simplify radicals with variables. Okay, So right now we were just working with numbers. I think we already did. I don't remember. But now we're going to be working with coefficients or with numbers as well, or variables as well. So what we're going to do first is simplify the coefficients, just like what we were doing above. Okay. Then we are going to divide the exponent of the radical by 2. That's going to tell you how many of that variable can get pulled out of the radical. Okay. So if there was x to the 8th power, we divide that by 2, and we get 4. That means that 4 x's can come out of the radical, so we get x to the 4. Okay. The number of times it goes into is the exponent on the outside. Okay. The remainder is the exponent on the inside. So we will have a remainder if it is odd. If odd, exponent always have one variable remaining. So like with my example with 8, if there's an 8, let's just say we're 7, okay? Well, x or 2 can go into 7, technically still 4 or 3 times evenly, but there would be 1 remaining on the inside, okay? Okay, so we're still going to break apart 48 here, okay? So the two numbers that go into 48 are 16 times 3. The square root of 16 is 4, okay? Our exponent is 2. How many times can 2 go into 2 evenly? 1. So I'm going to have 1x coming out, and then my 3 is going to remain on the inside. Because it is even, there is no remainder, okay? $72 can be broken apart into 36 times 2. The square root of 36 is 6. I'm going to have a x and a y. 2 can go into 4 2 times evenly, so my x is going to be squared. And 2 can go into 6 3 times evenly, so my y is going to be 3, and then inside of my radical I'm going to be left with 2. They're even, so there's going to be no remainder. My exponents are even. Okay. However, on this next one, my exponent is 3. So there is going to be a remainder. Okay. So I'm still going to break apart 20, and we will do 4 times 5. So I'm going to have a 2 on the outside. How many times can 2 go into 3 evenly? 1 time. So I'm going to have 1x on the outside. And then anytime that you have an odd, you will always have one of that variable remaining on the inside. So we're going to have 5x remaining on the inside. Okay. Your remainder is always going to be 1, okay, on the inside if it's odd. Okay. Always. All right. So we're going to break apart 8 into 4 times 2. So we'll have 2 on the outside. Hey, x is to the 5th. So we can go into it 2 times evenly. So I'm going to have an x squared. Okay. Can 2 go into 1? No. So the y will not come out at all. Okay. So I'm going to then have 2. I'm still going to have 1x remaining because my x was an odd number, and then my y. All right, so this was simplifying radicals without variables and with variables. Now we're going to be using this to help us solve quadratics, okay? Okay, so solving quadratics. We're going to get the squared term or expression on the side by itself, okay? Then we are going to take the square root of both sides. Remember that there's always a positive and a negative answer. That's when this comes into play. Because remember when we're solving quadratics, majority of the time we had two answers, okay? And then we are going to solve the resulting equation if needed. Okay, so for number 13, my square is already by itself. My x is already by itself. So I'm just going to square root both sides. So I'm going to square root x squared and square root 144. Well, the square root of x squared is x, because the 2 goes into 2 one time evenly. And then the square root of 144 is 12, but there's always a positive and a negative answer. So if we were graphing this quadratic, our graph would cross our x-axis at positive 12 and negative 12. Okay? Remember, these have two sides that are unique. Okay? So this is our answer, positive 12 and negative 12. You can write it plus or minus or write them separately if you want to. Okay, for this next one, I need to get the square root or the square term by itself. So the 4 is not being squared, so I need to divide by 4 first. So I'm going to get x squared equals 8, okay? Now I'm going to square root both sides. Well, 8 can be broken apart into 4 times 2. So I'm going to have x equals the positive and the negative 2 square root 2. So that's where what we were just doing comes into play here. So this gives me an exact answer, okay? So remember when we were graphing, if our line fell in between 2 points, like 0 and 1 or 2 and 3, we would just stay between 2 and 3. Now we have a precise answer. You are not giving me a decimal here. The only time that you would give me a decimal is if you're doing a real world situation, like at the end when we're doing a dropped object, okay? So if we're talking about shooting a basketball, okay, we wouldn't say it was 2 for 2 seconds and 2 point whatever. Okay. What? No. Okay. So here I have to subtract 8 from both sides. So I'm going to get x squared equals negative 6. Can I take the square root of a negative number? Try it. Type in your calculator, negative 6, and hit square root. We get an error. That's no. This is no solution. If this was a graph, like we were graphing beforehand, our graph would not cross my x-axis. So that is why it is no solution. Okay? So here we need to get our variable, the square term by itself. So I'm going to add 1 to both sides first. So I'm going to get 3x squared equals 9. Then I'm going to divide by 3 and get x squared equals 3. Then we're going to take the square root of both sides. So I'm going to have x equals, can 3 be broken apart? Is there a perfect square that can go into 3? No. So I'm going to have a positive and a negative square root 3. That's it. All right. So we need to get the square term by itself. So I'm going to subtract 5 from both sides and get 2x squared equals 36. Then I'm going to divide by 2 and get x squared equals 18. Then we're going to square root both sides. And I'm going to get x equals, and can we break apart 18? Yes, 9 times 2. The square root of 9 is 3, so this is going to be positive or negative 3 square root 2. Yes. You will lose points. This could also be written as x equals 3 square root 2 and x equals negative 3 square root 2. Okay? That's right. Either way. So this means that this graph crosses my x-axis at 3 point something and negative 3 point something. Okay? But this is the precise answer. Okay, so I need to get my n squared by itself. So right now it's being divided by 8. So I'm going to multiply everything by 8 to get rid of my fraction. So I'm going to have 8 times 6, 8 times n over 8, and 8 times 4. So I am going to get 48 minus n squared equals 32. Then I'm going to subtract 48 from both sides. I get n squared, negative n squared equals, or subtract 48, I'm sorry, negative 16. Okay, so right here, you might make the mistake of thinking that this is no solution, but there's a negative up front, so I need to divide by negative 1. So I'm actually going to get n squared equals positive 16. Okay? Then I'm going to square root both sides, and I get n equals the positive and negative 4. So this graph actually crosses my x-axis at positive 4 and negative 4. Okay? So numbers 19 and 20, they probably look familiar. They look kind of like vertex form. Number 19, if this was on the other side, so this is like 2x minus 3 squared minus 8, that would be vertex form. So if something's in vertex form, this is a great way of solving because it's like you don't have to graph, okay? You don't have to do anything. There's just a solve, okay? So what we're going to do is get the squared expression by itself. Okay, so in order to do that, I have to divide by 2 first. Okay, so I'm going to get x minus 3 squared equals 4. Okay, then we are going to square root both sides. So I'm going to get, okay, well my square and my square root cancel each other out because it's divided by 2. I'm going to get x minus 3 equals the positive and negative 2. Okay? So now, I'm not done yet. This is where that last step comes into play, where it says solve the resulting equation if needed. There is an equation here. X is not by itself yet. Okay? So I'm going to break this apart. I'm going to have x minus 3 equals positive 2, and x minus 3 equals negative 2. And now I'm going to add 3 to both sides. So I'm going to get x equals 5 and x equals 1. And those are my answers, my solutions. So for this one, I'm going to add 4 to both sides. So I'm going to get x plus 1 squared equals 20. Okay, we're going to square root both sides. And I'm going to get x plus 1 equals, and then positive or negative, and then we can break this apart. 4 times 5. X plus 1 equals positive or negative 2 square root 5. Okay, so now I need to solve my resulting equation. So we're going to break this apart. I'm going to have x plus 1 equals 2 square root 5, and x plus 1 equals negative 2 square root 5. So when I subtract 1 from both sides, I am going to get x equals negative 1 plus 2 square root 5. And then on this side, I'm going to get x equals negative 1 minus 2 square root 5. These are the more complex problems, okay? Okay, the dropped object model. Okay, this is comes into play when we have a dropped object formula, which is h equals negative 16t squared plus s, where h is the end height, t is the time, and s is the beginning height. Okay, so this is a real world situation. Okay, this is when we're not going to use decimals or square roots at the end. We will have a decimal. Okay, you won't have, again, 2 and 2 square root seconds. Okay, you would say 2.38 or whatever it is. Okay, seconds. All right, so a stunt man working on a set of a movie is to fall out of a window 100 feet high. He will land on an air cushion that is 9 feet above the ground. How many seconds will it take the stuntman to fall before reaching the cushion? Okay, so h is our end height. So my end height is 9 seconds. So we're going to have 9 equals, okay, then we are going to have negative 16t squared plus my start height, which is 100. Okay, I'm going to subtract 100 from both sides, and I get negative 91 equals negative 16t squared. I'm going to divide by negative 16, and I get t squared equals 91 divided by 16. They're both going to be positive because negative, negative. Okay? Now we're going to take t squared equals 91 over 16, and we're going to square root it. Okay? Now, this is where you guys can do this in your calculator. Okay? I'm going to have t equals, and we're going to take 91 divided by 16 in our calculator. And then we're going to hit the square root button. And then we'll round to like 2 decimal places. So we'll get positive and negative 2.38. Okay? However, would we have negative time? No. Okay? We would only have the positive side of our parabola. Okay? So that means that our time is just going to be positive 2.38 seconds.